Hello everybody and welcome back to Maths Miss Buick. In this video, this is the second video, we're looking at the 95% confidence interval for a population mean. So before we begin the question, let's recap on what is the formula for the 95% confidence interval for a population mean. So we have x bar plus or minus 1.96 sigma all over root n, where x bar is the mean of a random sample, or sigma is our standard deviation for our sample. I will often refer to as standard deviation as SD, and n is the sample size of our sample. And again, just to recap, why would we want to calculate a 95% confidence interval, or in other words, what even is it? Well, it is what it says on the tin. It is when you calculate an interval where 95% of your population lies within this interval. So this is example 2. In this example, we are finding the x bar. So here's the question. The 95% confidence interval for the mean height of 100 men with a standard deviation of 5 centimeters is 177.22 and 179.18 centimeters. Find x bar. Well, first of all, because we know it's a confidence interval, we're going to begin by writing out the confidence interval formula for the 95%. So let's begin that. So let's write down x bar plus or minus 1.96 sigma all over root n. And let's fill in what we already know. Well, we know what the n value is. So let's write down, well, the n is our sample size and we have 100 men. Or sigma is our standard deviation, how far away we are from our mean. And we can see there that is 5 centimeters. So let's underline the keywords. So 5 centimeters. So let's fill in those two numbers. So we have x bar plus or minus 1.96, or sigma is 5 centimeters, and we have root 100. Okay, we also know that we have our interval. So here is the answer to the negative part of our interval when we do the negative part down here, and this is the answer to the positive part of our interval when we use the plus. So let's make two separate equations and let's label these equations. So equation 1, we have x bar, start off with a negative one, minus 1.965 all over, let's change this root 100 to 10 while we're at it. And we're going to equal that to 177.22. So that's our first equation. So we're using our negative sign here, and that is the lower interval value. And now let's label our second one as equation number 2. And we have x bar, but this time let's use the positive sign. So we're talking about the positive sign here. 1.965 over 10, and we'll equal it to the larger part of our upper interval here, 179.18. And all we have to do is solve to get a value for our x bar. So let's look at these as being simultaneous equations. So let's put a line underneath these equations and let's add them. Okay, so how we would normally add simultaneous equations. So let's put a line across, and if we add them together, so when we're adding these ones together because they're of the same variable, this will be added together, and then we'll add our numbers together. But we can see here that when we add this and this together, they cancel each other out because one is a negative and one is a positive. So they're now gone. So let's add our two x bars together. So x bar plus x bar, in this case will be 2x bar. And if we add our numbers here together, we get 356.4. So then to get a value for the x, let's divide by 2. All divided by 2. So the value for our x bar in this question is 178.2 centimeters.